Hey everybody, this is Larry, this is me going Q4 of the weekly contest 458, longest palindromic path in graph. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. This one was really tricky. I think the first thing that I noticed is that n is equal to 14. I kind of thought about this as a sort of a ham cycle, maybe not a cycle, but ham cycle-ish problem. I thought immediately that I don't know a good way to do it. I don't know if it's NP, but it sounds pretty hard in either case, right? Whether it's an NP or not, I might not know the answer. But seeing that n is equal to 14 gave me an idea about like, okay, well, the first thing from that is that I knew that it would be some sort of, or I don't know that I knew that it would be, but it opened up the set of tools, right? That allows me to go, okay, well, maybe we can do something in 2 to the 14, right? Maybe times 14 times 14 square or something like that. Maybe even at 14 cube, right? I didn't do the math. What's 2 to the 14 actually? So maybe I should have done that actually. 2 to the 14 is 16,000. So maybe times 14 is 3 million. So maybe that's still a little bit slow. But I thought, okay, well, at least this opens up that sense of possibility. But yeah, and then after that, I just thought, well, I thought, okay, well, the next thing that I had to think was this palindrome thing, right? And this palindrome thing, honestly, maybe I should have, I think maybe the way that I thought about it, so I did get a wrong answer, but the way that I thought about it is a little bit wonky now that I think about it. Yeah, maybe I shouldn't have done it that way. Now, maybe we can make an optimization afterwards and it'll be a little bit faster. But in any case, my point was that, and well, we have to change some stuff. The way that I actually did it though was that I thought, okay, a palindrome, what does that mean? That means that beginning and the end is the same. So then I just took, okay, well, let's start with the left node and the right node, or left edge and right edge. They have to be the same, and then work your way inside. And I guess that's where I said, the other way is that if you start with the middle node and then go outwards, right? I don't know which one is easier to implement now that I think about it. I think going outwards is slightly easier, maybe, in that you don't have to worry about, like I got it wrong ends due to random edge cases. Not random, it's just I didn't take care of it. But I feel like that edge case would not come up if I had written it inside out. Because I was just not getting them to match. But in any case, yeah, so I was just working on the inside out, and the reason why that works is just that, well, you're taking care of the hardest part, the palindrome, and all the other stuff, well, it's going to be n square or something like that, where n is 14. So that maybe is good enough. At least good enough for me to get started on working on it. And this is my code. And this is also, you always wonder, like, I always try to test the worst case, and I just kind of write. And the worst case I generate with code, so that's what the worst case looks like. You have n equal to 14, all the labels are the same, so you test all of them. In any case, yeah. So the way that I did it, I'm going to go over the code in the way that I was thinking about. So immediately, I jumped to writing the thing, but I didn't have to index. I just thought, okay, well, we have the nodes that we used, and is it good enough? And I was like, oh wait, no. You need the index, because how are you going to know which node to connect to, right? So then immediately I go s index, e index, and I knew that this is going to be probably already sketched, but I also thought that it seemed reasonable enough, because used is going to be 2 to the n, where is 2 to the 14. S index is going to be 14. Or 0 to 14, or it's just n, whatever, right? E index is gonna. I also know that a lot of configurations are probably not possible, but if they were all possible, then it's just this, right? And in each state, we do a lot of work, and a lot of it is self-filtering, except for in the worst case. And I made a wonky optimization for the worst case, or the worst subgraph anyway, and we'll go over that in a sec. But yeah, but basically, because we are starting from the edges, we have like weird base cases, if you ask me, which is that, okay, if s index is equal to index, then we met at the middle, and then we just set this to 1, and then we return, because you only look at each node once. So if you're already in the middle, that means that you can't go anywhere and come back or something, right? So you just return one. If they connect to each other, and maybe I could optimize this a little bit, but if they connect to each other, then we just set best is equal to 0, because then now you have two nodes, they could connect to each other, and if they connect to each other, that means that, well, you're done. It's just based on the way that I calculate the nodes, so maybe that's a little bit confusing because we already counted it elsewhere. But we can still connect to other nodes that might connect, right? So we don't return. So these are my base cases, and then I keep track of how many. M is the n minus used, which is the number of free nodes. And the reason why I have this, actually, I commented out because I was curious after the contest whether this is fast enough. But yeah, but basically I wrote, okay, if the subgraph returns the best possible result, and I skipped ahead a little bit, but this is why I did it. If best is equal to m, then early terminate, right? Because, well, you already got the best possible answer. What else do you want, right? You may get unlucky and with funky things, and in that case, maybe you could randomly shuffle the input or something like that. But like against an adversary that could know it. But we won't go over that in a second. So then now this is also like meet in the middle, and the reason why we have this meet in the middle, wow, funkiness is because of the way that I counted it. Because you meet at the edges and you go on to the middle. I don't know how I feel about that, to be honest. It's very wonky. Like I said, if you work from the middle out, just like Piper, then maybe it would have been a little bit better. I didn't do it that way, so yeah. Otherwise, then it is just okay. I didn't go over what this means, but yeah. So basically, the invariant is that you and v has the same label, right? The nodes u and v. So then now we just look at all possible edges they can go from. And here you may write another ij loop from n and then do some comparison. But the reason why we have this CE is that I think I is just calculated edges and what and just short for it. And what this does is that for ij labels that are the same, we pre-calculate all the edges I connects to, and then why does this thing follows me? This is very annoying, actually. That didn't used to happen. J connects to, right? And then figure out which pairs keeps the same label. So then we can recurse on them. Basically, all this does is that we pre-calculate the label, the same thing. So then we put them in this calculated edge based on I and J. And we also, do the reverse thing. Keep in mind that the order matters, at least the way that I did it, right? Because I connects to U and J connects to V. And if you do it the other way, you're going to have a bad time, probably. Because then you probably just done something funky. I think in terms of states, it doesn't matter. And I think maybe we could have actually done a little bit better. Now that I think about it, maybe I'm wrong, in that we could have stored the results a little bit better if we just noticed the symmetry about S index, E index, and then maybe write something like if S index is less as E index, then we, or the other way around, I guess. E index, S index used, and then let's see. Yeah, and that makes it slightly faster. I think it took 3 seconds, and now this is 1.8 because we just skip all this stuff, right? So maybe I should have done that, and maybe I should have cache clear as well. But oh wait, no, that's it. But yeah, And yeah, slightly faster. But yeah, so after we get all the calculated edges as you saw, and this just the filtering for us early, and then it's just about this Bitmask thing. And in this video, I didn't talk about Bitmask, obviously. Maybe I should have mentioned it earlier. This assumes that you know Bitmask dynamic programming. There are a lot more easier problems with Bitmask dynamic programming, honestly. So I am not going to go over it in this problem. But keeping in mind that Bitmask is not impossible. It is just, it looks funky, and the operations with like weird different things in different languages. But honestly, you just think about use as a binary bit, or a bit array, a bit vector, if you will. It just contains 14 bits, and each bit can be 0 or 1. And if 0, that means the bit is not used. 1, that means the bit is used, right? So that means that if the fourth bit of used is 1, then the fourth node is used. That's all it is. That's all Bitmask is. It's just a way to kind of use an array of bulls, bulls or booleans, and just kind of keep that in 0 and 1. And then here we just have different way of checking it. That means that if it is not used, U is not used, and V is not used, then we can proceed. And this is just a bitwise way of going, okay, well, this used to be used, so then we just set U to true, and also V to true. And that's it. Yeah. And then at the end, we just brute force try every I and J, assuming that they have label, because we're starting from the ends, and then we just go inwards. Again, probably should have done inwards. I didn't even think about it until I thought about it, because as soon as I thought about it outwards in, I was like, oh, this sounds good enough. But I think if I had done it the other way, some of this code would be a little bit cleaner. But yeah, you just have to write it in terms of starting from 1 node and 0 node, but that's it. And yeah, that is all I have for this one, I think. I'm debating upsolving it using the other way, but I think the code mostly looks the same, so I don't think it's too interesting once you realize the ideas that you're doing it. But I just probably would have been cleaner. Like if I had thought about it during the contest that I could have done it from the middle, I would have coded that way, because and it takes a lot of experience and practice, but I think intuitively, for me, it just would have fewer edge cases in the back end. It would be like the edge cases are more upfront, which you can consider because you're starting from the middle. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and yeah, you can watch me solve it live during the contest now. Alright, I misspoke. Just a quick thing is that a quick thing is that I forgot to do complexity. We already kind of hand waved it here, but it is actually, so the number of inputs is equal to O of n squared times 2 to the n. And each input takes actually O of n squared time, because that's the number of edges inside and the calculated edges. So this is actually in the worst case O of n to the 4th times 2 to the n. But keep in mind that a lot of these states are not possible for a lot of graphs, which hopefully this one also filters it out. So that's why this is fast enough. And that's all I have for this one. Let me know what you think. Thanks for watching. And yeah, stay good. And you could watch me solve it live in the contest now. I'm going to skip ahead. I mean, I don't even have any ideas. I still have a problem to do, so it is what it is. Okay. Even though this is supposed to be harder. Okay. Okay, you have a graph. A label, okay. Most ones, okay. Well, n is equal to 14. So, and we want, is this a general graph? I guess so. Okay, n is 14. I mean, this is like a ham cycle thing, right? With like a variation IM cycle. We can try all. Can we try all of them? Or is it Bitmask DP? How would you structure this Bitmask DP? Is it meet in the middle? It's only 14, so that means that there are only 14 labels. Is this more? Is this? I'm trying to think whether this is more doable than Q3. I mean, right now they only show linked lists for some reason. I guess that reason is, I don't know. But I mean, it seems like it's going to be some Bitmask DP. Is it Bitmask DP or just Bitmask? Bitmask no DP? But Bitmask no DP is still 14 factorial though. How would you... I see. You meet in the middle to get the palindrome. Okay, I get it. Okay. So you just take 2 notes at a time. Because you... Okay, I see. Okay. I mean, this sounds crazy, but maybe it should work. Okay, fine. Okay. Okay. I mean, at least it's more... At least I have an idea. I don't know if it's fast enough, but at least it's an idea. Yeah, naming is hard. No, I don't care about that. Yeah. I do have to pause it though. Okay, and then now edges. Okay, maybe it's fine. I'm trying to think. I mean, it's got to be good, but no, it's not index. It's just mask, right? Okay. Let's go this Bitmask used. Yeah, okay. And I want max, so it's gonna be so then what is the best way to do it? I mean, we still don't want to write it too crazily. Okay, let's just say this is always going to be 1 if use is equal to or return. Well, we just return 0. Okay, then now I just change it to use. I feel like I'm used to using this, and that's. And then It's not just this though, is it? We still need to if we're starting at the net ends, we need 2 nodes. So that's going to be, let's just say, something like that. And now the best is actually maximum, so negative infinity. If s in the okay, so we are in the middle. Otherwise, this is just so yucky. But okay, what's it? 14 times. Okay, I mean 2 to the 14 times 14 square times an additional thing. But we could pre-process this actually, right? Yeah, we should pre-process this. The way that I pre-process it doesn't make sense. I think initially I did, but what I want is maybe after this. What I want is oh, and in this case, this is actually we have to return because otherwise you can visit the node more than once, I think, right? Something like that. So okay, return. This is very awkward. Let's add a comment. Okay. Otherwise, we want to. How do we pre-process? How would you write it without pre-processing? That's how you want to write it, right? Yeah. Okay. I mean, okay, fine. If it would be helpful if you spelled it correctly, but okay. Then now, yeah, I guess then it's very annoying. Yeah. Okay. If they're the same, then we want to just match other friends who are the same, right? Oops. 14 to the 4th is fine. Stop optimizing it. Okay. Then or 0, yes, 0 index. Use I for why am I using different? Okay. Then now we want to say combine edges. Something like this, maybe. Has to be that specific though, and we want it, or the order matters. As long as the label is the same, is fine. So it should have the same element. I hope this is roughly right. Okay. So that means that by thing it should be right. So then now we just go UV used, update used. Update used, Larry. Okay, I know. Update. Don't forget. +2. Yep. Okay. Update. What am I updating? Oh, used. So this is only if used and wait. No. Stop being dumb. Okay. I think that's it. Now we just brute force. I guess we can do this. I guess this is +1. Because then this implies 2 edges already. Oh, it only implies 2 edges if they're equal, right? So otherwise this is equal to just 1. I was gonna write it, whatever. Well, it's only 1 if n is at least 1. Okay. I feel like I get bitten by that from random things. Okay. 515, that's really not right. Considering we only have 4 letters, that's definitely not right. Okay. That's fine. Especially we have 3 letters. How does that work? Okay, fine. Zero to 5. Okay, so we want 0 and 2 to start and we have 5. Why? Oh, because this +2 is for the current character. So okay, so I'm wrong. That's fine, actually. If it is consistent, then it's fine. No, this is weird. What are you doing? Hang on. Okay, so this no, this should be the one with the +2. It doesn't make sense otherwise. It's either that or I just kind of put the +2 in the inside by accident. Okay, no. With the wrong parens? No, what? No, this is 2 plus that, so let's use. Huh? No, something's wrong. I don't want to. Zero, 2, 5, 1 and 0 and 2, that returns 3. Why? Why? Why would you return 3? Where are you going? Yeah, I was just trying to avoid doing this, but I guess I have to. Let's maybe I could just print that. We go to 1, 1. Oh. And then it returns 1. I guess this plus 2 doesn't really make sense, actually. No, okay. No, I mean... I think I'm inconsistent in how I'm defining it. Which is kind of sad because we're very close. But... Okay, fine. It's 2 for the current one, but that doesn't make sense. So then... What am I doing? Why am I so bad at this? Okay, you start, you have 2. Okay, that's good. You go to the next one. We want to move. If they're the same, we got 1. Otherwise, then now you do this. That's 2. Okay, I think this is right. It is very awkwardly written. 3, 1, 3. Am I confident? Not after that, but we can YOLO, right? We can also just test a big case because it should be easy to test a big case, right? Is it? Should be easy. Is it actually? I don't know. Should be the worst case. Okay, it's good that this is not good. Kind of. Why? Oh. Did I change something? Why didn't I? Huh. Was this always just wrong? Maybe it always did. I don't know how I didn't update that. It's a good thing we test though, because that would be a very dumb mistake. Time's out though. Or it's not running fast enough. Do 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 do. Why? Because there are a lot of edges. I don't want to do like some termination logic though. Did I do this right? I think I did this right. I just do one example. Okay, I thought I was close, but maybe not. With the timing, can I make an optimization? How long did it take? Yeah, how come this UI is so bad sometimes? Did it just not? Oh, it tells me to. It's like a button too. Okay, there we go. 7 seconds for the max case. We need to do better than that. Did something like this, but I always forget. Oh, well, yeah, I forgot to take this out. Otherwise it's going to take forever to test. Okay, so... I always forget what the syntax is, that's why I have to run it, which is kind of embarrassing. Okay, 5 has 2, okay. So then that means that max is going to be... let's just say, what is it? N? But that's such a hack, right? Because I guess it just makes a lot of the subtrees not possible, or whatever. Makes it really fast though. Am I YOLO enough? I guess so. What else am I? Ooh, what did I do? Oh no, I think I hit a shortcut for the next farm by accident. Okay. Alright. How do I... Oh, reset test cases? 1. Okay, fast enough maybe. But still not great. Am I confident? Not at all. Especially, I mean, I'm already not confident in normal things, but given Leetcode, even less confident. Okay, wrong answers. Surprising. Definitely surprising. Huh? Well, alright, what is going on? Alright, well, let's use this 1. I mean, just move forward, how can it be, I mean, probably because I've done something funky, but okay. So, which one is the 2? 2 is the L, so 0, 2. Okay, so this never triggers? Because S, oh I see, because S index is connected to E index, so, and then we don't mid in the middle correctly. So then the other mid in the middle is, if, I don't know, they don't have to though, they just can. Okay, well, and they do something really funky. Why? Where do they connect? Oh, because this is 2. Okay, this just means that S could be 0 and not negative infinity, because they can connect. Is that correct enough? I don't know, YOLO, submit. Oh, I thought it would time out, honestly. I mean, I think it's because I added this cheating branch thing, which is fine, maybe. I don't know. Don't have time to debate it, but wow, a lot of people got it. I thought only, I don't know. Alright. Hey everybody, thanks for watching. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this problem, this video, this contest, everything in between. Stay good, stay healthy, to mental health. I'll see y'all later and take care. Bye bye.